Hello everyone, welcome back to Deeksha Karnataka YouTube channel, and in the top 30 of the KCET 2025 series, today I am going to discuss the chapters units and measurement. And in kinematics we have two chapters. We have motion in a straight line and motion in a plane. So all the three chapters we are going to discuss in this session, and if you see this session, definitely you can answer 2 to 3 questions. This is a PU1 chapter. So PU1 chapters are usually less important, but if you want to practice, definitely this is the place where you should practice. Now let us start with the units and measurement chapter. Multiply 107.88 by 0.610 and express the result with the correct number of significant figures. Now if you see the answers, all the answers basically have the same value. Okay, all the answers are up to 3 digit, everything is same. Fourth digit is different, some cases 0, some cases 1, some cases 0. Here it is nothing there, right? So the problem is not about multiplication. Okay, so even though they have asked you to multiply, the question is multiplication, but it is not about how accurate you can multiply. Obviously the question is about significant figures. Okay, so what is the significant figure in this number? 1, 2, 3, 4, 5. What is the significant figure in this number? 1, 2, 3. Now this 0 is significant. Remember that 0 after a decimal, if it is at the last, it is significant. Okay, so 1, 2, 3. If it is after decimal, that is 0.01100001, then those zeros are not significant. This 0 is significant. So here we have significant figure 3. Here we have significant figure 5. Now when you are multiplying, okay, the result should contain minimum number of significant figure. Okay, so out of 5 and 3, the minimum number is 3. So the answer should have only 3 significant figures. Now if you see this option D, here we have 1, 2, 3, only 3 significant digits. So correct answer will be only D, not A, not C, not B. Okay, now let's move on. The vernier scale of a traveling microscope has 50 divisions, which coincides with 49 main scale divisions. If each main scale division is 0.5 millimeter, then the least count of the microscope is. So how to do that? So first of all, we have to find that what is the difference between main scale division by 49 by 50 into the least count of one division, that is 0.5 millimeter. Okay, so it will be 1 by 50 into 0.5 millimeter. So it will be 0.1 divided by 10, that is equals to 0.01 millimeter. So the least count is 0.01 millimeter. Option A is correct for the answer. Okay, this is also a practical based question. The same question can be asked, and you can say this is a practical based question. So this is a unit and measurement question. It is also a practical based question. Next, if P, Q and R are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? I have solved this question during my lecture. Again, let's check this out. So as I said, if two quantities have different dimensions, okay, then you cannot add them or subtract them. Okay, you can multiply them, you can divide. Okay, but if two quantities have different dimensions, you cannot add or subtract. Okay, multiplication and division is allowed, but subtraction or addition is not allowed. So direct subtraction and direct division is not allowed. So in this case, they are doing direct subtraction, which is not allowed. Okay, so this quantity is not possible. Okay, so this is the answer. Now let us understand why others are possible. For example, here we have multiplication and division only, so clearly possible. Now here we have, first we have a multiplication, here also we have a multiplication. Now if you multiply P and R, it is a newer dimension, not the old dimension, and Q square means it's also a newer dimension. So this is also possible. Okay, and division anyway is independent, you can divide it like this. So this is also possible. Okay, now in this case what happening is that we are multiplying two quantities. Again, multiplying two quantities means it is a new dimension, and that dimension can be equal to that of R. So this is also makes sense, right? P times Q can have dimension same as R, so that is why the subtraction is possible. Here also P times R can have a equal dimension to that of Q. Okay, Q square, so that is also possible. But P minus Q to different dimension, that means kg minus meter, is not possible no matter what you are dividing it with, right? So this is not possible, so this dimension is absurd. So this is the correct answer for this question. Now if you want to practice more such questions, then definitely you have to go to our channel. The link is given in the description, and it is Abhyas KCET test series, okay, which is available at a price of 1498. You will get 4 free tests and 31 paid. Some of you have already attempted the 4 free tests, okay, and the remaining 31s are paid. Here you will get full syllabus and chapter wise coverage. Questions are already available. If you purchase it right now, you will get all the chapter wise questions, and the tests are also slowly coming your way every day. Okay, you have to just purchase it and then log into the app and download the app, log into the app, attempt the question paper directly from the app. And if you have any doubts, you can check detailed video solutions, you can check the PDF solutions. Okay, there are chapter wise revision videos available as well. We have chapter wise insights for last 5-year KCET exam as well. Now if you don't want to attempt KCET, you want to attempt KCET, then that is also available as a crash course. It is a crash course where you will get complete detailed lecture by us. Okay, also you will get 12 tests included in the crash course. Okay, you will get complete syllabus coverage, you will get 5-year previous year questions, you will get live doubts solving session as well. Class notes and recorded division is always there, right? So that price is for 1999. So if you want to purchase KCET crash course, you can purchase that as well, right? Now let's continue with today's lecture. The dimensions of ratio of magnetic flux phi, and permeability mu are. Now this is a very interesting question. You might think that okay, flux is very difficult quantity, permeability is another difficult quantity. How can I remember all those complicated dimensions? I will leave it. So there is a way. So whenever you are being asked to find the relationship between two quantities, okay, maybe you are not sure what is the direct relationship between them. So how can you answer such questions? So in that cases, this is a particular case, you have to find the hook. Okay, so some quantity which is directly or indirectly related to each of them. Okay, so as we know that magnetic flux and permeability both are related to magnetic field. So we know that flux is basically B into A, right? Or magnetic field B is equal to phi by A, right? This is the relation. Now what is magnetic field inside a solenoid? We know that it is given by NIA. So maybe they do not represent the same thing. One represents flux and one other represent magnetic field, but in some cases they cannot be directly equated as well, but dimensionally they can be equated. If they are related to same quantities, their dimension should always be equal. Okay, so dimensionally this relation has to be correct. So what we are trying to find, not NIA, my mistake, it is mu naught Ni. Okay, not NIA, sorry, it is mu naught Ni, or in this case only mu we will write. We'll assume there is some dielectric medium inside the solenoid, so it is mu Ni, and we are trying to find the relationship between phi by mu. Okay, phi by mu that we are trying to find, and that will be equals to NA into I, right? This A will be going here, this mu will be coming over here, so NA into I. Now what is N? N is number of turns per unit length. So N is basically distance to the power minus 1. Okay, per unit length means per meter, per centimeter, right? So it will be distance to the power minus 1. Area, what is the dimension of area? Dimension of area is L to the power 2, but I think I made some mistake. No, it is fine. Now what is current? Current is ampere, which is A. Okay, so now what is the dimension? Dimension will be L into A. This is the dimension of phi by mu. So what is L? And all of the other things are 0. So L to the power 1, A to the power 1. So if you see option A, M0, L1, T0, A1. So correct answer is option A. Okay. Now next question. The ratio of the dimensions of the Planck's constant and that of the moment of inertia has the dimension of. So this type of questions are very common. So Planck's constant, now in some cases you don't know any relationship between Planck's constant and moment of inertia, two completely different quantities. So in that case, if you remember the units, that will be very helpful. For Planck constant, unit is joule into second. Okay, and moment of inertia I equals to m into r square, right? So m into r square means kg into meter square. Okay, so in this case it will be very helpful if you remember the units. So what is joule? Joules is kg meter square second to the power minus 2. Okay, joule is basically force into displacement. Force is kg meter per second square, and you have to multiply with one more displacement, that is m. So kg meter square plus second square, second to the power minus 2 is joules, and second is another second is multiplied, and in the division we have kg meter square. So kg cancels, meter square cancels, second cancels, you have only second to the power minus 1. Second to the power minus 1 means what? Which of the following quantity has second to the power minus 1 unit? Only frequency has, not time. Okay, second to the power minus 1 means basically cycles per second, or also known as hertz. Okay, per second is basically nothing but hertz. Okay, you know this unit as hertz. So hertz is frequency. Now next question. A physical quantity Q is found to depend on the observables x, y and z obeying the relation Q equals to x cube y square by z. The percentage error in the measurement of x, y and z are 1%, 2% and 3%, 4% respectively. What is the percentage error in the quantity Q? So for that you have to do one thing, dq by q. Okay, dq by q, and that will be nothing but whatever is this number to the power number into dx by x, plus errors always add. So y square 2 dy, y square means it will be 2. Now this question I think is partly out of syllabus, but anyway there is no harm in knowing this simple formula. Okay, so y square is 2 dy by y, and plus z is in division, anyway does not matter, power only matters, so it will be dz by z. Okay, it does not matter, everything errors always added, so you don't need to worry about it. Now what is the percentage error in x? X is 1%, so 3 into 1. Okay, so basically this, if you multiply everything with 100, it converts into percentage. Okay, plus 2 into dy by y is 2, so 2 into 2 plus this is 4%, so 4, and entire is percent. Okay, so it will be 3 plus 4 is 3 plus 4 is 7, 7 plus 4 is 11, so total error is 11%. So correct answer is option A. Next question, which of the following is not unit of time? Second unit of time, minute unit of time, month unit of time, light year is unit of distance, it is not unit of time, so this is not an unit of time. If x equals to a plus bt plus ct square, where x is the meter, then and t in second, then what is the unit of c? So x is in meter, so if we are writing an equation a equals to b plus c plus d, then individually every one of them should have same dimension as that of a. That is the meaning of a dimension relation, right? So x should be same as ct square. So dimension of x okay, should be same as dimension of CT square. Okay, or dimension of C will be equals to dimension of X divided by dimension of T square. Now what is the dimension of X is in meters. We are trying to find the unit, so we will, instead of dimension, we will directly put the unit. So unit X is in meter, so it is meter, and this is in time, so second square. So meter per second square is the unit of C. So C is basically an acceleration, right? Meter per second square. Next is, which of the following physical quantity has the dimensional formula of ml square to the power minus 3? M to the power 1 is not okay. So ml square t to the power minus 3. So very interesting. So we have seen that ml square t to the power of minus 2 is the unit of work, but we have one more extra to the power minus 1. So this is the dimension of work. So work divided by time, that is power. So this is the dimension of power. Okay. Next, an object is moving through the liquid. The viscous damping force acting on it is proportional to the velocity. Then the dimensions of the constant of proportionality is. So the viscous force, viscous drag force is proportional to the velocity. Okay, 6 pi eta RV, right? That is the formula, but we are not interested in the formula. What we are interested is, if we make this kV, what is the dimension of this K? That is what we are interested in. Okay, so we know that K will be equals to force divided by V. What is the dimension of force? Dimension of force is very important to remember, ml t to the power of minus 2. And what is the dimension of velocity? Velocity is distance by time. So distance by time, L t to the power of minus 1. So L cancels. So you get K is m, okay, L to the power 0, t to the power of minus 1. So minus 2 divided by minus 1, it will be only minus 1, right? So m to the power 1, L to the power 0, t to the power of minus 1. Correct answer is option D. Okay, now let's move on to the next chapter, motion in a straight line. Okay, a body is moving along a straight line with initial velocity v0 and acceleration a. The average velocity of the body over the given time interval is, final velocity is v. Okay, so it is moving, started with a velocity v0 and acceleration a. Okay, final velocity is v. So what is the displacement? So displacement time is also given. Okay, so you don't have to do anything. So only thing you have to do, you have to find the formula that v square equals to v0 square plus 2as. Okay, or s equals to v square minus v0 square divided by 2a. This is the displacement. So what is the average velocity? Average velocity is very simple, s by t. So v square minus v0 square by 2at. Okay, so this is the formula. So v square minus v0 square by 2at. So correct answer is option C. Next question. The displacement x in meters of a particle having mass m in kg moving in one dimension under the acceleration of a force is related to time t by t is equal to square root of x plus 3. The displacement of the particle when the velocity is 0. So how to solve this? This is a very common question. So t equals to root x plus 3. So root x equals to t minus 3. So x equals to t minus 3 whole square. So what is velocity? Velocity is dx by dt, which is nothing but 2 into t minus 3. Okay, you can check it, it will be same value. Right, now when the velocity is 0, that means this is velocity. Velocity is dx by dt, right? First order differentiation. So velocity is 0 means t minus 3 is 0. So t equals to 3 seconds. The velocity is 0. Now what is the displacement? So you have to put it back over here. So displacement will be 3 minus 3 whole square, that is equals to 0 meter. So answer is 0 meter. Okay. Next question. for a body moving along a straight line, the following VT graph is obtained. Okay, body moving in a straight line, the following VT graph. So VT graph, if you can see, let me draw it. So it is moving like this, then this, okay, and this is something given. Okay, now the displacement during, so obviously as you can see from here to here, the object is accelerating. That is why VT graph means, for a VT graph it is going up, that means it is an accelerated motion. Here on the other hand, during this time it is going in a constant velocity. So say from 1 to 2 the object is accelerating uniformly, and from 2 to 3 the object is moving with a constant velocity. Okay, now let's see. The displacement during uniform acceleration is greater than during uniform motion. So this area is definitely not equal to this area. Okay, this area is bigger because this much is missing. So if this area, if you consider this much area, so this much area, if you minus it from here, you get the complete area. So that means first option is incorrect. Uniform acceleration is less than that of during uniform motion. Yes, the displacement area under the VT graph represents the displacement, right? So uniform acceleration is definitely less. So correct answer is option B. Let's check the other options. Uniform acceleration is equal, not equal. Uniform motion is 0. Uniform motion is not 0. So basically uniform motion is, so this is uniform accelerated motion, this is uniform motion. Now uniform accelerated motion, if the interval is fixed, interval is same, that means this area will be less compared to this area. Okay, clear? Now next, at a metro station a girl walks up a stationary escalator in 20 seconds. If she remains stationary on the escalator, then the escalator takes her up in 30 seconds. The time taken by her to walk up on the moving escalator will be. So first, you have all went to a mall, shopping mall, right? Shopping mall, there are an escalator. So first the escalator was not working. Okay, like the one escalator in the railway station, right? They don't work always. You have to either walk it up or climb it down, right? So if the escalator is not working, okay, the girl takes 20 seconds to walk. Okay, suppose the displacement is S. Okay, the total displacement is S, and she takes some speed V. Okay, slowly she walking up, so it takes 20 seconds to climb up. Okay, now when the escalator is working, okay, and the girl stands on it, okay, and at that time the time taken by the escalator to move her is 30 seconds. Okay, so what is the velocity? You have to find the velocities of individual cases. So velocity in the first case is S by 20, and this is the velocity of the girl. Velocity of the escalator is S by 30. Now when both are moving, when both of them are moving, the velocity will be addition of the girl's velocity and addition of the escalator velocity, that is S by 20 plus S by 30. Okay, so what will be the time taken by it? So time taken by it will be again S by V, which will be giving you 1 by 1 upon 20 plus 1 upon 30, which is nothing but 20 into 30. So you can consider them to be a parallel combination. So 20 plus 30. So it will be 20 into 30 divided by 50, 0 cancels, 5 6 30, so 12 seconds it will take. Okay, so this is similar to that of the parallel combination in such cases, and it is 12 seconds. Next is this question. The given graph shows the variation of velocity v with position x for a particle moving along a straight line. Which of the following graph shows the variation of acceleration a with position x? Okay, so here it is a acceleration versus displacement graph, and here you can see that velocity versus x graph. So velocity is decreasing with x. Okay, so velocity is decreasing, that means now it is not a velocity time graph, this is velocity displacement graph. Okay, so definitely as you can see that as the displacement is going, so object is slowly slowing down and it is becoming 0. okay, and it is uniformly decreasing. So velocity is proportional to negative x, okay, as x increasing, velocity is decreasing, right? So velocity is basically v naught minus, this is v naught, this is v naught, so velocity is equal to v naught a into x, okay. So a is the constant of proportionality, and also from this graph we can see that what is this a is nothing but the slope of the graph, okay. So if you take delta y and if you take the delta x, so this is the slope of the graph theta, and because the theta is on the opposite side, it is negative, okay. That is the meaning of it. So basically this graph represents y is equal to mx plus c, but here m is minus a and c is v naught, that is the starting position, right? Now what we have to find, we have to find what is the relationship between acceleration and x, okay. How to do that? So to do that, what we have to do, we have to differentiate this thing, okay. We have to differentiate, or okay, let's do one thing. At the starting point, we will take this equation. At the starting point, t equals to 0 and the velocity v equals to v naught, right? So velocity v equals to v naught, so definitely final velocity is v naught. So what we get is that ax is equals to 0, okay, ax equals to 0. And at the final position, when they are meeting over here, v is equals to 0, okay, v is equals to 0, and we get ax equals to v naught. So we get that a is v naught by x, okay, a equals to v naught by x. So acceleration is not 0 over here, and now at this position x is equals to 0. We are not sure whether acceleration is 0 or not, but x is definitely equals to 0. It is basically a constant, it is a uniform motion. Velocity is decreasing uniformly, it is not any curved motion like this or this, so it is decreasing uniformly. So it is basically the value of acceleration is v naught by x, and it is a constant, okay. So as you can see that here this graph is giving you the same value, it is a constant deceleration. So constant deceleration means option D is correct answer. Anyway, this calculation is not super helpful. Anyway, basically you have to understand that because it is a graph, straight line graph, that means it is uniform motion. So uniform motion means definitely uniform deceleration, so it will be like this, right? Now let's move on. A particle shows distance time graph as shown in the figure. The maximum instantaneous velocity of the particle is around the point. So if you see that during this individual points p to q, delta y by delta x, right? Delta y by delta x is the slope, right? Now distance by time, distance is y, distance by time gives you the instantaneous velocity, right? So delta y, in this case delta y by delta x gives you the distance upon time, that is instantaneous velocity. So if you want to find, say, around any point, okay, so first of all what we will do, we will try to find the instantaneous velocity around p. So let's say this is the point we are considering. Now we are trying to find at q, okay. Around q, if you see that y is also more and x is also more, okay. Now suddenly from q to r it increases suddenly, okay. So around r it will be maximum, and for s it is again started decreasing. So basically from starting to almost close to r it is very constant, but suddenly just near r it decreases, increases super fast, okay. The graph is like this. So around r it increases super fast, and from r it starts decreasing. So the instantaneous velocity will be maximum at the point r, not any other point, okay. Next question. A car moving with a velocity of 20 meter per second is stopped at a distance of 40 meter. If the same car is traveling at a double the velocity, the distance traveled by it for the same retardation. So most of you will answer 80. or it is option is not even given here. Let's see. So initial velocity is 20 meter per second, and the stopping distance is 40 meter. Okay, so we know that v square is equal to u square minus 2as. Okay, so here it is u, v is 0 and u is 20 square equals to minus 2 into a into 40. Okay, so deceleration we have to calculate first. So a is equals to 20 square divided by 2 into 40. Okay, so that will be 20 into 20 divided by 2 into 40. So it will be 2, 10, it will be 5. So it will be 5. Acceleration is 5. Now if you put that value over here, the next equation again, it will be, now we are trying to find s equals to u square by 2a. So u is now is double the initial speed. Double means 40, 20 is double is 40. So 40 square divided by 2 into 5. So same car means that deceleration will remain same. Okay, when the car is moving with some speed, if you are applying brakes, that means the deceleration of the car is same. So that is the main funda of this question. So 1600 divided by 10, 0 0 cancel, so you get 160. Okay, so 160 meter is the answer. Now next question, a body falls freely for 10 seconds. Its average velocity during its journey. So it falls for 10 seconds starting from 0, right? So what is the starting velocity? Starting velocity is 0. What is initial velocity? Velocity is not important anyway. We are trying to find what is the displacement h. What is the displacement h, and time is already given 10 seconds. So what formula we will use? We will use s equals to ut plus half at square. Now s is given by h, u is 0 because it started falling from the rest, and half gt square will be there. G is 10, t square is 10 into 10, right? 10 second. So 5. So height is 500. Okay, now what is the average velocity? Average velocity is displacement divided by time. So 500 divided by 10, that is 50 meter per second is the average speed. Okay, so average speed is 50 meter per second. Everything will be second, okay, per second, not second square. Obviously second square will be its acceleration, which is constant. The velocity time graph for two bodies A and B are shown. Then the acceleration of A and B are in the ratio. So here we have velocity and time graph. Okay, so velocity divided by time is basically velocity divided delta y. Delta y is velocity and delta x is time. So velocity divided by time gives you the slope, and that is also the acceleration. So for the first point A, what is acceleration? Acceleration of A is delta y by delta x, which is equals to, so if the angle is given, slope becomes tan theta, tan 25 degrees. Okay, now what is this angle? This angle, this small angle is given 40 degrees. The small angle is given 40 degrees. So this entire angle will be 60 degrees. Right? This entire angle will be 60 degrees. So acceleration of B is tan 60. Right? Now you have to remember that tan less than 45 degree is less than 1. So tan starts with 0, right? At tan 0 is 0. It slowly increases up to 45, it becomes 1, and then it keep on continue to increase till 90 degree, right? So as the angle increases, the value of tan increases. Okay, so tan 25 is much smaller compared to tan 60. Tan 60 value we know, tan 30 value also we know, but tan 25 we do not know. If you consider this angle to be closer to 30, we can say, okay, this is 1 by root 3 and this is root 3. So definitely root 3 is bigger. So what is the ratio of their acceleration? Oh, they have asked you to ratio of the acceleration, nothing else. So ratio of the acceleration is tan 25 is to tan 60. The answer should be tan 60, not tan 50 anyway. This is the closest answer. This is the closest answer, that's why you will take, because if this angle is 40, this will be for 50 only, sorry, my mistake. 90 minus 40 is 50 only, not 60. Okay, so it will be tan 50. Okay, 90 minus 40 is 50. This angle is 90, so 90 minus 40 is 50. Anyway, so the answer is option A, tan 25 to tan 50. Okay, next question. A body starts from rest and moves with a constant acceleration for t seconds. It travels a distance x1 in the first half of its time and x2 in the next half of the time. Then, so body starts from rest and moves with a constant acceleration. Constant acceleration means A is constant and it is moving for a time t second. Okay, it travels a distance x1 in the first half of the time. That means x1 for time t by 2 and x2 for time t by next t by 2. From 0 to t by 2 is this, and from t by 2 to t is this. Now, how to solve this question? First, what we will do, we will start with the distance x1. It is easy, it is starting from the rest. Uniform acceleration, say acceleration is say a, so x1 will be half a t square, here t by 2 square. Okay, so this is the starting point. Okay, now what we will do, we will find the total distance travel, say x, okay, starting from rest and at the end of the time, that is a t square. Okay, what is the beneficial thing about this? First half this travel this distance, and this is the total distance travel. So what is the distance traveled in the second half? Distance traveled in the second half is total distance traveled minus distance traveled in the first half. Okay, so it is basically half a t square minus half a t square by 4. This is t square by 4, so half a will be common and you get t square minus t square by 4, that is 3t square by 4. Okay, so this is the x2. Now what you have to do, you have to find the relationship between x1 and x2. So easiest way to do it, you divide x2 by x1. Okay, half a will be cancelled, you get 3t square by 4 divided by 1 by 4, that is equals to 3. So x2 equals to 3x1. Okay, so x2 equals to 3x1. So even though the acceleration is not given, time t is properly not given, you can still find the relationship between x1 and x2. Now next chapter, motion in a plane. A particle is in uniform motion, uniform circular motion related to one complete revolution of the particle. Which of the among statement is incorrect? Displacement of the particle is 0, displacement is 0, complete motion means displacement is 0, average speed of the particle is 0, average speed is not 0, average velocity is 0, average acceleration is 0, but average speed is not 0, average speed is total distance travel divided by time, total distance travel is not 0, that is 2 pi r. So average speed is not 0. Next question, two objects are projected at an angle theta and 90 minus theta to the horizontal with the same speed. The ratio of their maximum vertical height is. Now if you throw theta and 90 minus theta, okay, what happens is that their range is same, okay, but vertical height can be different. Okay, so what we have to do, you have to check the vertical height relation and then we have to find what is the formula. So vertical height formula is u square sine square theta by 2g, right? This is the formula for vertical height. Now first one is projected with sine theta, so this is h1, and h2 is same formula, u square sine 90 minus theta square by 2g. So if you divide it, you will get h1 by h2 is equals to sine square theta divided by cos square theta, which is tan square theta. So the ratio will be tan square theta is to 1. Okay, tan square theta is to 1. So correct answer is option C. Not 1:1. 1:1 will be for the range. Complementary angle, range will be same, not the height. Now maximum range of a gun on a horizontal plane is 60 km. If G equals to 10 meter per second square, then the muzzle velocity of the of a shell is. Okay, so horizontal, the maximum range is 16 km. Okay, G is 10 meter per second obviously given. Then the muzzle velocity of the shell is. Now how to find the maximum range? Okay, maximum range is maximum when the angle of projection is 45 degrees, right? When the angle of projection is 45 degrees. Now if you project it with a say velocity v, okay, what is this component? This component will be v sine 45. Okay, now v sine 45 is 16 km, means time. Now the horizontal range formula is given by v square sine 2 theta by g, right? So sine 2 theta obviously 45 degree means it is 1. So range is 16 km. V square we are trying to find, and g is 10. Okay, now remember here 16 is in kilometers. Okay, so what we have to do, we have to convert it into meters. 10 to the power of 3 into 10 equals to v square, or v equals to 4 into 10 to the power of 2, that is 400 meter per second. So you have to be careful and check the options once you are solving. Okay, so here it is given in kilometers. So if you miss that out, then you will not be able to solve this question. Now next question, the trajectory of a projectile is parabolic in the absence of any air resistance or any resistance. Okay, now for a projectile motion, the angle between the velocity and acceleration is minimum and acute. So projectile motion, the angle between the velocity and the acceleration, so angle, let's see, there you have projected a object like this. So this is the direction of velocity. Okay, and this is the direction of acceleration. Okay, so velocity is like this, acceleration is like this, and this angle is maximum. Okay, obtuse angle. At this point angle is 90 degrees, and as it is moving from here, okay, velocity is in this direction and acceleration is in this direction. Okay, acceleration is in this direction, and at this point the velocity and the acceleration basically becomes minimum. Okay, only one point, that is at this point, at the just before touching the ground, the angle between the velocity and the acceleration is always downward. Okay, just before touching the ground, the velocity and the acceleration, the angle between them is acute and minimum. Okay, now next, a particle starts from the origin at t equals to 0 with the velocity of 10j meter per second and moves in xy plane with a constant acceleration of 8 I cap plus 2j cap meter per second square. At an instant when x coordinate of the particle is 16 meter, y coordinate of the particle is. So particle starts from the origin t equals to 0 and with the velocity of 10j meter per second. So as you can see that there was no component of the velocity along x direction, but there is a component of acceleration in the x direction. So along the x direction, ux is 0, ax is 8. Okay, and the displacement is given by 16 meter. After some time its x coordinate is 16 meter. So we have to find what is the time for that. So time for that, what formula we will use? We'll use s equals to half at square. Okay, so x is 16, equals to half into acceleration is 8, so it will be 4 into t square, so 4 cancels 4, so t equals to 2 seconds. So we have calculated the time. Now the object was moving with a constant speed. Object is moving with a not constant speed, initial speed of y equals to 10 and its acceleration along y is 2. Okay, so time we have calculated 2 seconds. So what will be the displacement sy? So it will be ut plus half, it is positive, right? So half ay t square, so uy is 10 into 2 plus half ay is 2 into t square is 4, so half cancels, you get 20 plus 4 which is 24. Okay, so it will be 24 meters. Next question, a wheel starting from rest gains an angular velocity of 10 radian per second after uniformly accelerated for 5 seconds. The total angle through which it has turned. Okay, so angular velocity is 10 radian per second, time taken is 5 seconds. Okay, we will use the same formula. And here we have to find the total angle through which it has turned. Okay, so angle is basically theta. So v square is equal to u square plus 2as you can use, or you can use theta equals to s plus half at square, but for that you have to first find the alpha. Alpha is 10 radian per second uniformly, and the time was taken by 5, so 2 radian per second square was the uniform acceleration. So what is theta? Theta is basically, first of all you have to convert it into radian, then if required we will try to find it out. So theta is equals to ut plus half at square, right? In this case of angular velocity, it will be omega t plus half alpha t square. Now omega initially it was 0. Okay, so omega t is 0. So alpha we have calculated is 2. Okay, so half into 2 into, and time given is 5 seconds, so 5 square. So it will be 5 square is 25 and it is radian. Okay, because everything is in radian. Same formula you can use for rotational motion as well, only everything has to be in the rotational dynamics. Okay, so 25 radian is the answer for this question. Now next question, the trajectory of a projectile projected from origin is given by the equation y is equal to x minus 2x square by 5. The initial velocity of the projectile is. So the projectile motion is represented by y is equal to x minus 2x square by 5. Okay, now you can use different formulas, but you know that the formula, one of the most easiest formula to remember is that y is equal to x by tan theta minus some formula, some initial thing. Now you have to remember that at the beginning when you are throwing it out, okay, x equals to 0, y equals to 0, both are 0. When it is reaching the maximum point, y is equals to height, and when it is touching the ground, okay, this is equals to range, and range is basically x equals to range and y equals to 0. So these are the things that you have to remember. Okay, now also this is another part, there is some constant into x square. Okay, if you remember the value of the constant you can use directly, but if you don't remember the value of the constant, you at least have to remember the constant term involved with x. So this is divided by tan theta, and as you can see here it is divided by tan theta is 1, so tan theta is equals to 1, that means theta is 45 degree. This information is required from this. And the second one what we will use is that at x equals to r, y is equals to 0. So we will put 0 equals to r minus 2r square divided by 5, or r equals to 2r square by 5, or one of the r will be cancelled and we get r is equal to 5 by 2. Why I am doing it? Because we know the relationship of the equation of the r, which is equals to v square sine 2 theta divided by g. Okay, so now use sine 2 theta is sine 45, sine 90, which is 1. So v square equals to 5 by 2 into 10, okay, 5, or v equals to 5. Okay, v equals to 5 meter per second. So you can remember the exact equation, which is I don't recommend, because that might come, that might not come. But if you have super time and if you are super interested, you can remember the entire equation, or you can use the logic that at x equals to r, y is equals to 0. It will take some 10 seconds extra, but still you can solve this question well within 1 minute. Now next question. If A is equals to 2i cap plus 3j cap plus 8k cap is perpendicular to B equals to 4j cap minus 4i cap plus alpha k cap, then the value of alpha is. Now two vectors are perpendicular, that means A dot B equals to 0. Okay, if two vectors are perpendicular, A dot B equals to 0. Now how to find the dot product? 2 into 4, 8 minus 4 into 3, 12 plus 3 into 8, alpha into 8, okay, plus alpha into 8, 8 alpha equals to 0, right? That is the rule of dot product. I multiplied with I. I made a mistake over here. I multiplied wrong numbers. Okay, so this is J. So J multiplied with J. So 4 into 3, 12 minus I plus 2. So minus 4 plus 2, it is minus 8. Okay, and then we have 8 into alpha. So 8 alpha equals to 0. Okay, plus and minus only error would have happened is plus and minus. So 4 plus 8 alpha equals to 0, or alpha equals to minus half. So minus half is the answer for this question. Next question, the angle between velocity and the acceleration of a particle describing uniform circular motion. So uniform circular motion, okay, acceleration is always inward, centripetal acceleration. Velocity is always tangential. So the angle between them is 90 degrees, always. Okay, so the angle between velocity and acceleration in case of uniform circular motion is always 90 degrees. With this, I am concluding this session, and if you have any doubt, any questions, don't forget to mention in the comment below. I'll be back with the part 2 of the PU2 tomorrow. Till then, bye.